This is the QuickField simulation example, coil with ferromagnetic core. Now we are at QuickField.com, and here this is the example web page, and one can find the detailed description for this example here, the geometry and the electric circuit linked with this this FEM problem, and also we have the problem properties here, like magnetic permeability of materials, conductivities, and so on. Our task is to determine the electric current within the coil winding. Okay, let's go to QuickField and create this problem. So, new problem. This is the problem of transient magnetics. Model class is axisymmetric. So, and also we will add a circuit file. Okay, let's proceed. And also we should set the timing parameters. We will calculate up to 0.2 seconds with the step of this value. So also we will store the results at every step, since this value of time. Okay. Well, the geometry of the coil is pretty complex, so we will import this geometry from the DXF file. Okay, now it's done. Now we will label the geometrical model blocks and the edges. So this is the coil. Or winding, doesn't matter. This is the steel core. And this is the air. This thin layer is air as well. On this arc we will have the boundary conditions of magnetic potential. This is the axis of rotation. And on this edges we will have a boundary condition of symmetry. Okay. Now let's type the values. First for the air. For the winding. We suppose that winding is made of copper. And the steel core is nonlinear. So the properties are given in the BH curve. Okay, now it's done. Now let's set the boundary conditions. On the axis of rotation, we have magnetic potential Ra equal to 0. Here on the arc called faraway, we get the same boundary condition. And on these edges of symmetry, we have a zero field. That is a zero tangential field. Now we can build the mesh. So we have finished dealing with geometrical model, and now let's create a circuit. First, I add the voltage source. Can rotate it as I want. Then I should type the value of the voltage and the law of alternation. We have a source of AC current. Then I insert resistor. After that I insert block from model. Link it with the circuit. And also I should add this capacitor here with the value of 5 microfarads. Oh, the circuit is completed. And now I can solve the problem. It will take some time. This is the magnetic field picture. And now we can go to the circuit post processor Here we can choose winding block and to look at the plots of voltage and current. That's how it looks like. A plot of current and a plot of voltage. This is the magnetic field picture, and now we can go to the circuit post-processor. Here we can choose winding block and to look at the plots of voltage and current. That's how it looks like. A plot of current and a plot of voltage.